Let's see how we go there. Okay, I'll be covering a very brief introduction to what I'm calling the right way to do climate change economics, in fact economics in general, and then the way it's been done by neoclassical economists, which I would say I've spent 50 years, as some of you are aware, being a critic of mainstream economics. I led a student revolt at Sydney University in 1973, which was the only one of its kind at the time, and it led to the creation of a Department of Political Economy at the time, revolting against neoclassical economics. So I've got go back, I can date myself back to 71, in fact. So it's 50 years anniversary of being a stirrer about this stuff comes up next year. And I wrote Debunking Economics, as some of you would know, in 2000 as well. So I've read an enormous amount of neoclassical economic literature. Without a doubt, the worst that I've ever read is the stuff on climate change. Not just because of its consequences, which are of course why it matters, but because it's the lowest grade shit, and pardon me, but that's about the only expression I can use, I could ever imagine. So I want to take you through what things should be doing and what they've done, and why it's desperately necessary that we get rid of them from any advice on climate change whatsoever and develop an alternative. So the right foundation. This is a quote from a 1920s scientist who was similar to Stephen Hawking in the sense of being a leading physicist and also a promulgator. Okay, Sir Arthur Eddington. He was the person who empirically proved Einstein's theory of general relativity by going out in a ship to a position in the ocean where there was a star, a known star of known magnitude, which was going to be covered by the sun at some point in the rotation of the Earth around the sun. And Einstein's prediction, I think, was of a 0.8 arc change in the angle of light, gravity bending light. Okay, so he did the empirical proof of that. So he's no dummy. Okay, he's also a popularizer in the way that Hawking's was of science too. And he made this comment in a book about physics for the general public, saying the law of entropy always increases holds, I think, the supreme position in the laws of nature. If someone points out to you your pet theory is inconsistent with Maxwell's equations, which is of course where quantum mechanics began, then so much for Maxwell's equations. If it's contradicted by observation, well, experimenters sometimes get things wrong. So, but if your theory is found to be against the law of second law of thermodynamics, I can give you no hope. There is nothing for it to but collapse in the deepest humiliation. Does anybody know here what the second law of thermodynamics is?
Everything goes from more concentrated to less concentrated?
Yeah, fundamentally. If you imagine this room and I manage to compress all the air into it, into one square cubic centimetre up there, that is actually a more ordered state of the air in this room than it is at the moment. So when you open it up, it diffuses, and that's the fundamental concept of entropy. It's involved in what's called statistical mechanics. But in the colloquial ways, you go from more order to less order over time. Now that's an essential law of physics which is violated by every theory of economics. Not just the neoclassicals. Normally I trash neoclassicals and I promote post-Keynesian. And as it happens, post-Keynesian is more easily made consistent with these laws than the neoclassical. But all of them have theories of production that don't involve energy. If you look at the way that they model this circular flow diagram you would have seen in your textbooks, it has firms buying inputs from factor markets, selling them in product markets to households, and all nice and loops and all self-contained. Here's another one. It's commonplace vision in economics. There's no non-economic input or output from that vision. Okay? Everything is produced in the economy, nothing gets dumped from the economy anywhere else. This goes well beyond the concept of externalities, by the way, in case some of you are thinking that covers what economists need to do. What you have is all the inputs are produced by the economy itself, and all the output is consumed in the economy. That's what that vision says. Now it implies that you can produce all the inputs you need, including energy, which is impossible. That's the first law of thermodynamics. Energy is neither created nor destroyed. You change the form of energy by using it. It changes in its own interactions with other matter as well. But you cannot produce or destroy energy. Okay? So in that sense, if you had a self-contained system of the economy, it couldn't make its own energy, therefore it could produce nothing. That's the first violation. The second is that it's showing nice order all the time. There's no waste being dumped anywhere. Okay? There's no waste dump inside the model. There's no waste being dumped outside that model. That violates the second law. Okay? If you're going to do useful work, you must generate waste. And that's something economists have never got their heads around because of the stupid myth of perfect competition, where you get the maximised supplier and there's no dead weight loss in the perfect market, perfect this, perfect that, etc., etc. And you can't produce output without waste, period. And you cannot get rid of it and you cannot recycle it. Ultimately, there's some you simply can't use. Those laws are all violated by the neoclassical vision and by, incidentally, but in much more correctable form, post-Keynesian models. So you want to get things happening inside the economy if you can exploit freely available energy. We didn't pay for the sun. Okay? We didn't make the sun. Happens to be there. If it wasn't there, we wouldn't be here either. So we get this free stuff from the planet. Solar energy, fossil fuels, and nuclear energy. So we can't produce it. That's the first law. We can only exploit energy that currently exists. We've got to find it first of all. And that includes converting matter into energy, nuclear power. That stuff comes out of supernova explosions, or actually beyond supernovas to some extent. And if we're going to exploit that energy to do useful work, you necessarily generate waste. You can minimise the waste, but you cannot eliminate it. And those are the second and third laws. And if you're going to make that diagram realistic, then you've got to at least have energy inputs from the non-man-made, non-person-made environment. And you've got to have waste being injected back into the environment. Those are the two necessities to make it work. So something like this might work. You have the sun, and you have coal, which is, of course, accumulated sun. And you have nuclear energy, nuclear isotopes, the fissile isotopes, or the other end, fusion. You then take that energy in. That energy is used to do useful work inside the economy, and the economy has to dump waste back inside in the real world. I've actually got to move that arrow across. I just realised I should have it coming out of the economy bracket there, so I'll do that later for the slides. Now, the question is, why can't we produce without using already existing energy? And why can't we produce without producing waste? Well, they're called the laws of thermodynamics, and they were derived empirically initially by observation. And the only way to make sense of them was found by a guy called Boltzmann, and from that we got a lot of modern physics. And they were discovered in the late 19th century, and I really can't criticise neoclassical or Marxian economists all that much, post-Keynesian didn't exist back then, for not including it, because it was happening in parallel time in a different discipline. And unfortunately, academic silos were not quite as strong back then as they are now, but they still existed. So most of them didn't read. Most of the economists did not read the physicists, did not understand their ideas. Marx actually did, to some extent. He did read them. Yeah, I think he got a copy of Boltzmann's book sent to him. So he does have some content inside there, but the labour theory of value violates these laws as well. And so the neoclassicals didn't know it. They were actually influenced by physics about 20 or so years earlier, which Philip Mirowski. Has anybody heard of Philip Mirowski? You haven't? Okay, Mirowski. Very good philosophy of science. Rather verbose, Phil, but a very good philosophy of science. And he described the physics on which economics piggybacked itself as energetics, which I think is a good term. They were aware of energy, they hadn't worked out what it was yet, fundamentally. The word energy was first coined in 1809, okay? And the concept was still, it wasn't finalised until the 1870s. And that was, of course, when we got Walras and Jevons and Menger giving us neoclassical economics and the Austrian variation. But they simply weren't up with the physics then. They're up with stuff about 20 or so years earlier. Now you need it is very complicated mathematics. I will not pretend to understand those laws. I learn them, I forget them. You've got to be applying them all the time to do them well. One of my good research colleagues, Tim Garrett, whom I also another name to look for the name Garrett, by the way, Garrett, Tim Garrett, to see a different way to do physics economics from a directly thermodynamical point of view. It's best to put it across by a joke, which comes from a guy called Allen Ginsberg. You ever heard of him? Hey, at least one. That's my first score for the evening here. Okay. He wrote a joke version of the laws of thermodynamics, and the first joke was, it's a three-part joke. 1, you can't win. 2, you can't even break even. 3, you can't leave the game. Exciting, isn't it? You're in a game, you've got to lose. You can't get out. Now, putting it more informatively, you can't win, you can only break even, which means you can only take a certain amount of energy and get an equivalent amount of work out of it. 100% is the best you can do. You can't generate more. You can only break even if you can find somewhere to dump the waste from the process that's extracting, using energy, which is at absolute zero. 0 Kelvin, minus 273 degrees Celsius. Okay? There is no such place. Okay? Those are the basic laws of thermodynamics. So you can neither create nor destroy energy. Only its form can be changed. The maximum you can do is limited by the background temperature into which you dump the waste from the work process. Only if the background temperature was 0 Kelvin could you actually turn 100% of that energy into work. Okay? So you've got to have waste. Can't get rid of it. So that's the basic idea of the laws. Now, the second law, to give you some further concepts behind it, that's why you have cooling towers. If you've seen cooling towers as you go past thermostations or any form of power station, that's why. Because they can't extract it in a closed system. It must be open to the environment to some extent. Now, what you have is something like this. You've got a boiler where water gets superheated, turns into steam, high pressure, turns a turbine. Turbine goes through a condenser to reduce the temperature, okay, and then goes back as cold water on the other side, and the process is repeated. Now, if you weren't dumping that into the environment, you get no energy out of it, because ultimately the heat level in the combined boiler, turbine, condenser, if you weren't taking any energy out, temperature get to be the same. Steam would be the same temperature and the same pressure on one side of the turbine as it was at the other, it wouldn't turn. Okay? So you've got to have that dumping to cool it down so you can take it, and that's an essential part of generating the energy. So waste is inevitable. Without waste you wouldn't do useful work. Now this is something engineering students learn from day one. Okay? Think of how dumb you are as an economist not having learned this yet. Not your fault. It's what you're being taught. That's how much you've got to revise what you're being taught. That's how far the need to change economics goes. So, what you have now, of course, and this stuff began back at a time that William Baumol described as the cowboy economy. Wide open spaces. Okay? 1870s America, what's your image of that? You know, cowboys and Indians expanding into the open spaces, etc. Colonialism, etc., etc. We're now on what Baumol also called the spaceship economy. Okay? We're at the constraints, which neoclassical economists will deny, which shows how stupid they are. Okay? However arrogant they might be in denying it's they're being stupid, not you if you protest to them. So we have nothing fundamental to say about either of those laws, about the role of energy. So can we make them consistent? And this is something I worked out about 3 years ago in this total serendipity way. How do you bring energy in a meaningful sense into the theory of production? And I had a colleague, Bob Ayres, who is a ex-physicist, he actually is the guy who invented the term externalities. Okay? So he's never got the recognition for it, but he's worked in environmental economics and ecological economics and physics, the interface between physics and engineering and economics for many years. And his house is full of statues, as it was at the time. I was walking through the room late at night, as one does, and had this little brainwave: labour without energy is a corpse, capital without energy is a sculpture. Okay? Now I sat down, and about 5 minutes later I had the solution. I thought, is that all? Is it that obvious? Is that simple? But it was. What you have to see labour and capital as is not factors of production, as neoclassical theory describes them, but means to convert energy into useful work. Now, unless they're getting energy in, they can't do that. So if you didn't get any energy, you'd be dead. Okay? If you have a machine without energy, it's a sculpture, it won't turn. You've got to put energy in. And then they convert that energy and use that energy to convert other forms of matter into something useful. So what I'm just doing here at a very simple level is using E capital lambda, the Greek L, and E capital kappa for the energy inputs into workers and machines. And I'm going to replace labour at time t and capital at time t, which is the way things like the Cobb-Douglas production function are stated, as labour using energy at time t and capital using energy at time t. Different forms of energy, of course, but you have to have the energy input to get any output. Now, there's no... and you also, as you show, you can't get away from waste either. And you also must have less than 100% efficiency. So this all stuff catches up with what the laws of thermodynamics require us to do. I'll stuff this up down there, pardon me, I'll talk about that in a moment. So I bring in Q as a way of describing output in terms of energy. I'm not talking in widgets now. If you think about the y equals, k to the alpha, L to the 1 minus alpha you would have done have you all done the Cobb-Douglas reduction function? Do you know it's garbage? Okay, one more name for you. SHAIKH, shake, and look for a paper called the humbug production function. Okay? The reason the Cobb-Douglas fiction function fits the data is it's a nonlinear regression of 1 against 1, which tends to get a pretty high correlation coefficient. It's a myth. It's been known in non-orthodox economics for about 40 years. But anyway, I'm just using it here to illustrate. I prefer using the Leontief form, which actually is empirically more accurate and logically, as I don't think I show here, but I can cover that later. So you say output in terms of energy now is labour using energy input either the lambda at time t to the 1 minus alpha, k using energy input k kappa at time t to the alpha, standard form. And I'm just going to define the energy input from labour as the number of workers times the energy that an unskilled labourer can put into production, the energy that the unskilled labourer consumes times the efficiency with which that is turned into useful work. Now, if you think about yourself, the amount of energy you consume, any idea how much you consume on a daily basis, say in terms of, the old 100-watt incandescent light bulbs? Okay. That's roughly how much energy you can put into work. If you hop on when you hop on an exercise machine bike and you start pedaling, check the number of watts you're maintaining. About 90 to 120 watts is the normal range. How many watts do you consume? About 25 times that. 25 times. No, 250 times. It's huge. We're consuming far more energy than we take out. Okay, but the product, the last two terms there, these two, EL and E, multiply them together. That's been a constant for the life of humanity. Roman slaves could also sit on an exercise bike and pump out 120 watts. Okay? But they didn't get much more from their slave owners. Okay? So the product of the two, the energy input times the efficiency, is pretty much a constant. Now, the other one for capital, the number of machines times the energy consumed per machine times the efficiency with which that's turned into useful work. And I've jumped ahead of myself there. Number of machines, by the way, being a very disputable concept. This is probably a new way to measure them. But have you heard of the name Piero Sraffa? S-R-A-F-F-A. Okay, those of you who haven't, look up Piero Sraffa. So that's the way to put it together. Now, when I don't take you through the technical stuff here, I can, if you'd like, later. But what's called the solar residual. Have you heard of that at all? Some of you have. Okay. It's the amount of using the standard Cobb-Douglas production function when they did what they call growth accounting and try to say how much of change in output is due to change in labour and change in capital. 85% of the answer was something else, which they finally called total factor productivity, and that's the A term in the Cobb-Douglas production function. So that is actually the energy contribution of the average machine for its time. I give a recent, if you look at the exponents that are used in this, the alpha and the 1 minus alpha, they're actually based on the distribution of income. So labour, this value of this component used to be 0.7 or 0.75, now it's about 0.6. It's just the distribution of income, and capital gets the remnants of that. That's just based on income distribution and the idea of the marginal productivity theory of labour, marginal productivity theory of income distribution. That goes away when you do this analysis down here and find you should have a much higher exponent for the capital because you're working purely in energy terms. There's a paper of mine in the Journal of Ecological Economics that goes through all that. And what you get, things we call a capital output ratio is actually how efficiently machines convert input to useful work. What we call labour productivity is actually the ratio of energy inputs of labour to machinery. So the whole thing gets transformed quite radically from a very simple change. And I want to illustrate part of this here, that the solar residual, as I said, is the energy consumption of a machine. Now, if you think about the James Watt steam engine, that consumed about 10 tonnes of coal per day. Okay? If you think about the leading machine of today, I would say is the Falcon 9. Musk's Falcon 9, consumes 9 tonnes per second, okay, of fuel. So that's 23,000 times as much fuel over time. That's why the Falcon 9 goes a bit faster than the James Watt steam engine, okay? The amount of energy being consumed. So we can actually link, with this idea, we can link economics to ecology because, first of all, you must have energy input to produce output. Secondly, you have to have waste. Biosphere pollution is a necessary side effect of production. And CO2 is simply the most prominent form. Okay, the other equally, ultimately I think will be as important in terms of destruction of the environment we live in. Okay? It's not just carbon dioxide we generate, it's a whole lot of forms of waste. But that's a necessity of production. And we also have the dilemma of what's called the energy return and energy invested, which is something which is a serious issue in how quickly can we move across from non-renewable to renewable forms and whether it's sustainable and so on. There's a huge debate on that area, which is well worth leading. I just want to show you can actually put an economic model out of this together. So this is just an illustration. Has anybody here heard of Richard Goodwin? One? Hyman Minsky. Okay, well my Minsky model is built on Goodwin's model. If you've seen my model of Minsky, okay, it's based on Richard Goodwin's model. And I wanted to show what's possible in this model. So imagine you have a feedback in effect in the model. I've got a pollution feedback, I'm just illustrating for the sake of it, but also I've got a feedback of exhausting fossil fuels. If there were only fossil fuels, then what would happen over time? Of course, that's not the case. There's more restrictions than just that, but I always want to show that. And you necessarily accumulate waste. So what I've got is a model here with fossil fuels in them, and I'll just bring it up in my software package Minsky. I'm happy to talk through the logic of this at a later stage. This is what's called a system dynamics model. Anybody ever seen anything like that before? Yeah, one or two? Okay, you can download that from the what's called the SourceForge website. So what I've got is an energy input here with it from an energy stock. It can be multiplied by capital, giving you a level of output. Output itself, the use of that capital, the energy depleting the reserves of energy, producing an output but also producing waste. Okay? So if I simulate this model, initially everything looks absolutely fabulous. You've just got the cycles going on indefinitely, and the Goodwin model is a model that gives you indefinite cycles, by the way. No garbage about equilibrium conversions, which is nonsense in a complex system. But over time, you start to deplete the energy resources up there. I've set it up so it goes for about 200 years, which is about the duration of that magnitude between Smith and where we are now. And now you find right towards the end of it, down goes your reserves, cycles start to collapse, good night economy. Okay? That's the sort of very, very simple conceptual foundation we need to start from. That's what we should be doing, that sort of modelling, rather than the nonsense neoclassical economists have done. So, looking at what they've done, they use a Cobb-Douglas production function without energy. Now, I can't blame them for that because, I've just developed this thing in 2016, published early last year. So, I can't criticise somebody for not beating me to my idea. But they put it in what's called a Ramsey long-run growth equilibrium growth model. Are you aware of that? If you ever learn what a real business cycle model is or a DSG model, it's based on the Ramsey growth model. Paper in 1928 in the Economic Journal, worth having a look at. Not as bad as the people who built their stuff on it. Now, what I thought once I'd done the stuff on energy and I felt like I could actually make a contribution, I thought I've got to read the neoclassicals, particularly after Nordhaus won the Nobel Prize in 2018. And I thought what I'd be criticising in them was just using this Ramsey growth model, equilibrium framework, and Cobb-Douglas production function. That's quite complicated stuff to have to explain to people. And there's the idea, I've got to show production involves energy and climate change is not an equilibrium process, so you're using the wrong tools. That's what I thought I'd have to say. Instead, it was far worse than I could possibly have imagined. Well, I could have imagined it, but every time I think how bad they can be, they go below my expectations. They make a set of absurd assumptions, and now they call these things simplifying assumptions. In fact, they're assumptions on which their conclusions depend. Okay? So if I assumed that wall was transparent and ran at it, okay, that's not a very good assumption. If the assumption wall is transparent, I'll get through to the other side, no problem. If it's not, I'll get myself a concussion. That sort of assumption. They assumed making an assumption like the wall is transparent. That's why they call it a simplifying assumption. Yeah?
You know that Richard Cole works here and gives climate change economics?
Yes, I do. I was wondering if he's going to be in the room. I would have continued exactly as I am now. His work is amongst the worst I've ever seen.
I have this book at home.
Good. Don't burn it, bury it. They've been involved in fabricating data. There's no other way to describe what they do. And yeah.
Can you give any examples?
Pardon?
Can you give any examples?
Can you wait one slide? Believe me. The trouble is, I can't stop giving you examples. Each new paper I turn up has got some piece of total garbage in it.
These assumptions.
Huh?
Of these assumptions.
Yeah, they're coming up on one slide, I think. No, there's actually a couple of slides. So they're not just academic researchers, of course. It's quite natural for the IPCC to ask the established experts in each field to contribute that section. So they asked mainstream economists to contribute to the IPCC report. And who's studied from Toll here? Who's doing a class with him? Anybody?
I did.
Okay. I think you can see it's his writing style, okay? He was the lead co-author, one of the two lead co-authors. So he's saying, impact of climate change should be small relative to other change. Changes to population, age, income, relative prices are more important, okay? Trivia, in other words, changing sales tax and changing tariffs is more important about long-term economic outcome than climate change. That's what he's saying there. And when you look at the annual losses, they're saying the global annual losses for an additional increase of about 2 degrees are between 0.2 and 2% of income. Trivial. Not a reason to be out in the streets, okay? And that's just showing, So, yes, I'm talking about your lecturer. Now, that's rounding error stuff. If you look at these things, in 100 years' time or 50 years' time, the GDP might be 2% smaller than it is now, in the complete absence of climate change. So that's rounding error in terms of the rate of growth. You might go 0.05% slower. That's a statistical aberration. That's well within the error bands for actually estimating today's GDP. So it's no worry. There's no wonder that the politicians don't worry about it. Now, what it's based on is a range of assumptions that when I read them, I just think, who's writing this? Primary school kid? Activities that occur indoor are assumed to be unaffected by climate change. Okay? You haven't read this stuff, have you? Go and look in the forensics. Here's again from the EP. This is from the IPCC 2014, page 688. Other economic activities such as manufacturing and services largely take place in controlled environments and are not really exposed to climate change. As we simply assume anything you can air condition won't be affected by climate change. I wish I was joking. This is a conversation I provoked him into on Twitter just recently. Humans move indoors, air conditioned. Outdoor work mechanised. Tourism flows reversed to cooler spots. They also, having assumed, that's one assumption. The second assumption, if you actually try to work out the relationship between GDP and temperature across the Netherlands, you could work out the per capita income of Groningen? I can never pronounce it. I'll never get it right. And Amsterdam and Hague, etc., and work out the variations. You get a whole lot of scatter plots, and you could fit that scatter plot with a parabola, and then say that's the relationship between temperature and GDP. So therefore, if there's an increase in temperature equivalent to the change between what's the coldest place in the Netherlands? It's pretty hard to say, isn't it? I got to take America, which is what they did. The change in temperature GDP relationship you can find today between a cold spot in America, a medium spot and a hot spot, that'll tell you what's going to happen when the global temperature rises by the same difference. Okay? And here we go. Again, just showing, I'm not talking ancient stuff, I'm not talking stuff which has been assumption and then simplified, taken away later. 10K is less than the temperature distance between Alaska and Maryland, about equally rich, or between Iowa and Florida, about equally rich. Climate is not a primary driver of income. Are you aware he believed this?
Yeah, I am.
You are good. Okay, that's why I'm giving this talk. And what I'd also call outright distortions, let's be polite, of existing literature. This is Nordhaus in 1991. saying in a paper called which will be bother, slowing down climate change. And what he has there, there's only a few, notice this number here, he's talking about the impact of climate change in various industries. So farms, he's got a potentially severely infected sector, impact on greenhouse warming and CO2 fertilisation. And look at the range, minus 10.6 to plus 9.7 billions of $1981. That's without discounting. Okay? Now, I'm going to come back to that and say that's not a bad, I'm not angry about that figure, given what he says is the way he derived it. Because down the bottom here, he says underlying data on impacts are summarised in EPA 1988. I don't trust this guy. I don't trust any neoclassical economist. So I went checking, and thank God I found that was the draft report. I found the final report. That's what the final report had to say. I'll note it back over again. The damages, minus 1.65 billion from electricity demand. So he said, he took the numbers, processed them, and got minus 1.65 as the impact of damages to electricity demand. That's the actual figure, 33 to 73 billion. Now the out that he's got, and I presume what he had, the EPA says, assuming no change in technology or efficiency. So I think what he did is one of the few terms I like from Paul Krugman. He talks about the technology fairy. Throw the technology fairy something at that. Just assume we can have a rate of technological change, which means $33 billion cost without technological change and efficiency gains will be only 1.65. But the rate of technical change it takes to get that figure down is about 4 or 5% per annum. Now that's about 2.5 to 3 times what we estimate the rate of growth of technical change of the technology to be over time. Now, there's no explanation, and notice there's a range stated here and a single number there. Now this one here, that minus 10.6 to plus 9.7, is precisely what is in the report. Okay? It's exactly what the report says. So he just copied that. This was much larger than he wanted it to be. So somehow he dreamt up that. And when you look at it in terms of the amount of GDP, that's 0.07% of 1 year's GDP in America, the figure that he gave. The figure that's given by the EPA there is between 1.3 and 3% of GDP. Now, if you factor that in and you try to fit a curve, you're fitting it to a much bigger number. Okay? Everything he's done is about minimising the numbers quoted about the damages from climate change. He also justifies using a quadratic, which of course, parabola. It's the simplest function above a straight line. Okay? And it's continuous, there's no discrete jumps, it doesn't increase rapidly in slope at any point. And he says the current version assumes the damages are a quadratic function of temperature and does not include sharp thresholds at tipping points, but this is consistent with a survey by Lenton. This is the 2013 manual for his DICE program. You can find that online. So, what did I do? Went looking for Lenton. It wasn't in his bibliography, just being sloppy, but it was a manual. It wasn't an academic paper. But I found the paper. This is the actual conclusion. Society may be lulled into a false sense of security by smooth projections of global change. A variety of tipping points could reach their critical point within this century. The opposite of what he said the conclusion was. And I keep on finding this. You ever heard the joke about a young kid who's just dangerously optimistic? Runs across the road because he's sure he'll be faster than the cars. Jumps off cliffs because he's sure he'll land in the water. And his parents get so worried, they decide to give him a wake-up call with a present for Christmas. Huge pile of horse manure. That's all he gets in the morning. He opens the parcel, it's full of horse manure. The parents come out in the morning and find the kid absolutely enthusiastically digging through the horse manure. And the parents say, "What are you doing?" And the kid says, "Well, there's so much horse manure, there's got to be a pony in here somewhere." Okay? That's how he interprets virtually every piece of data. The old what's it called? Life of Brian. Always look on the brighter side of life. He always looks on the brighter side of statistics, but so much so that he completely distorts what he said he's fitting the data to. And what he's really doing, this is Nordhaus I'm talking about now, is bringing in pre-existing biases and trying to make up numbers to justify them. So this is in the 1991 paper. It must be recognised that human societies thrive in a wide range of climatic zones. Yes, that's true. It's got nothing to do with climate change. We're not talking about physically moving your location from New York to Nevada or the other way to Miami, and therefore getting a geographic variation. We're talking about massively changing the amount of energy in the biosphere. And not by our own direct actions, but by simply the blanketing of the atmosphere with extra carbon dioxide, which lets less light reflect back from the sun than comes in. And that's what's causing it. The amount of energy, there's a recent calculations here, is equivalent to 5 Hiroshima bombs a second for the last 40 years. That's how much additional energy is being absorbed. Okay, we're not dumping that ourselves, we're not creating that heat ourselves. But in terms of the heating of the ocean, when the measurements were done, the number of joules necessary to raise the temperature of the ocean from what it was 40 years ago to what it is now is equivalent to letting off in that ocean 5 Hiroshima bombs a second for 40 years, roughly. Okay? So that's the amount of energy. Now that is a gigantic transformation of the energy in the biosphere. And what they're doing is mistaking the weak and non-relationship you can find between GDP and temperature today, which is fairly insignificant determinative income, as Toll keeps on saying, for what's going to happen when we dramatically increase the amount of energy being retained in the biosphere. So, and then this one. This is again from that 1991 Nordhaus paper. He says 3% of output is produced in highly sensitive sectors, another 10% moderately, and 87% in sectors that are negligibly affected by climate change. And then the same thing, it's difficult to find major direct impacts. So that's where your position you started from. And then finally, in that particular paper, 3 degrees warming, 0.25% of national income. Okay. Now, if you read people like Mark Linas, that's another book I recommend, Linas, Mark Linas, paper called 6 Degrees. He goes through what the paleontological I need a drink here, not a beer, paleontological record of climate implies for the sustainability of life on the planet. And you're getting to the point there where the serious breakdowns are occurring compared to what we're used to. Now, they also, when they look at the way the damage is taken into account, the damage is seen to hit the flow of output from the machines, not the damage of the machines at all. The damage function is applied to GDP, which is the flow of output from our machinery, not to the machinery itself. So you have this damages reduced GDP here. That's the relationship. But capital and technology and population are unaffected. So all the feedbacks you would want to see in a well-done model are not in those models. Okay, it's just affecting the output. K and L and K are just growing completely. So here is the sort of stuff that politicians are reading. If you wonder why they dismiss Greta Thunberg, lip service but ignore it, and policy continues on. This is what they're reading. I know what politicians are like. I've dealt with enough. They get a staffer to go and read the paper. They say, tell me what the economics section says. Not interested in science, but most of them are lawyers, or they did economics degrees at university. They don't understand engineering. They don't understand science. They couldn't. You see, when Boris Johnson was saying that recently to the woman he sacked as the head of COP26, he didn't understand it. Well, fair enough. He's trained as a lawyer. He can quote Latin at you. Doesn't understand engineering or physics. So that's what they read. And they come back and say, oh, well, yes, sir, 3-degree temperature increase will cut income by 2.1%. Why the hell are the students outside demonstrating then? I'll go and say something nice to the cameras, but I couldn't really give a shit about it. This is what Linas had to say. At 1 degree Celsius increase, the Midwest American Dust Bowl will come back. And this is looking at the record and saying what actually did happen at different temperatures in the past when the pattern of continents on the planet was much the same as they are today. So not leaving up continental shift effects, of course. At 2 degrees, parts of the Southern Ocean become toxic to plankton. Calcium carbonate, a necessary part of their production process, no longer works. So there goes the plankton supply. Now have a guess what that means to food supplies. Okay? At 3 degrees, the temperatures in the Gulf of Mexico will drive winds of up to 180 miles an hour, okay, about 300 kilometres an hour. Now that wipes out the strength of current storms we're seeing, and you've seen the damage done by recent force 5, it'll be force 6. We'll need new categories. There won't be as many, as it happens, by most of the theories. Again, not as many storms because there'll be more uniform temperature as it happens potentially across the globe. But that'll be the speed of the ones that occur. Been watching the fires in Australia recently? I certainly have. It's where I come from. I have 2 sisters who are in one case, within 40 metres of a major forest, the other within 20 metres. The forest actually comes to their property. The fires stopped 6 kilometres from one sister's property, thank God, and the other one, thankfully, the land hasn't caught fire. Now, this is saying at 4 degrees, there'll be no more agriculture there. Well, where do 23 million people move at that point? At 5 degrees, this is probably the scariest of the lot. There's what's called methane hydrates. The methane cladrates is another term for them. That's at the very bottom of the ocean, under enormous pressure and cold. Methane fuses, in a sense, with H2O, with water. And there's enormous stores of it there under enormous pressure. As the temperature rises, particularly about the 5 degree mark, this is again looking at the historical record, those methane hydrates separate, the methane starts to rise to the surface. Of course, as it rises, it expands dramatically because you're going gas under huge pressure to a gas at ocean level. They say that the estimates are when this came to the surface, almost always exploded with the force of a small atomic bomb. That'd be an exciting place to go surfing, wouldn't it? Okay. At 6 degrees, highly unlikely human species will survive, looking at the levels of extinctions that have happened in the past at those temperatures. So these are the levels that are being trivialised by neoclassical economists. But he gets the Nobel Prize. Yeah.
So I get your critique on the assumptions and everything.
Yeah.
And I also see why you criticize the data, but I don't see why Nautilus should have an incentive to actively push down his estimates.
He believes capitalism can solve all problems. He actually talks about the incredible adaptability of human society. He does what he calls a survey of experts in, I think, 1994 or thereabouts. 19 people were surveyed, by the way. Of those 19 people, 3 were scientists, 10 were economists, the range of other professions in the middle. Okay? And in that, they just talked about how economists are so aware of the incredible adaptability of human society. Whenever you throw at a market system, it burps and says, what's next for breakfast? Fundamentally, that level of belief. It really is just ideological. It comes out of seeing capitalism as a system that has equilibrium all the time. It's a disease of the mind caused by economic theory. And I want to show. When you look at it, how the hell did they get away with it? The answer is, again, the refereeing process. I don't get to referee their papers, okay? They get to referee their own papers. This is what happens in I know it, I've seen myself. Okay, I get papers sent to me to referee, which are papers based on work that I've done myself. It's automatic. Because of that, sometimes I obviously make mistakes. Okay? And I've done that in refereeing. But they have a mindset, a groupthink, which Toll himself actually talks about in one of his papers. A groupthink. As long as you fit inside the groupthink, you don't get criticised. So the stuff gets through and gets published and gets the so-called reputation of being peer-reviewed. The only real standard, which we don't apply in any science, unfortunately, is replication. Okay? If you applied replication to that paper from the EPA and said somebody else take a look at the paper, see if you get $1.65 billion as the damage from electricity, and look and see 33 to 73 billion. Okay, so the forensic type I'm stuff here is not done. I'll give you a personal example of that, and this is my fault. My paper, the Goodman model I showed you beforehand, was the basis of me doing a model of Minsky. And in the late 2000s, I think, I got sent a paper to referee by a guy who did an empirical study of the Goodman model as applied to 10 OECD nations. And he concluded it fitted the data badly. The cycling that I showed you in the model, that turned up in the data, that was okay. But the equilibrium point predicted for the combination of wages share of GDP and employment was way outside the actual loops of each of the 10 countries. And I was a bit disappointed by that, but I solid table of numbers, 10 countries shown, all the standard deviations, blah, blah, blah. And so I begrudgingly said, okay, well, it's, well done research, so yes, published. I'm disappointed, but I made a couple of points back as to how you could modify it, but put up with it. Then a few years later, I decided to use his data for the Phillips curve to feed into my Goodwin model. And I tried graphing it, and I got these crazy results. The numbers just were insane. So I wrote to him and said, David, I tried to use your numbers, and they just gave me this ridiculous slope for the Phillips curve and ridiculous values. What's going wrong? He said, sheepishly, he's a good guy. He said, I made a simple schoolboy error, quote unquote. And that was that he'd done the regressions using percentages and fed them into a model with decimals. So he's using 70, we should have used 0.7, that sort of thing. And when you corrected for that, the Goodwin model fitted the data pretty damn well, which colleagues of mine have shown in a recent paper, Matthias Griselli and a colleague. So this sort of stuff happens. It's just what happens in academic literature. But when it reinforces itself as it has here, you get a really dangerous little group of group thinkers who continue reproducing the same stuff and actually compete with each other to reduce the level of damage they're finding, which is what they've been doing. This is the sort of sociology I've seen in their behaviour. So, a bit of a digression, but I hope it helped. So back to here, look at these slides. This is in his Nobel Prize lecture. And that's the thing which, I thought, holy hell, how does he get this? His optimal time path, notice these things here, base, optimal, okay? There's your base, which leads up to a temperature level in 2150 of about 6 degrees warmer than pre-industrial. There's your optimal. Okay? 4 degree temperature increase. Why is it optimal? Because it minimises the cost of abatements and the cost of climate change. So if you have no abatement, again looking at the next chart, this is again from the Nobel Prize speech, 6 degrees above pre-industrial levels, net present value 23 trillion, zero abatement, 23 trillion total cost. Optimal abatement, the 4 degrees, damages of 15, cost of 3. And then you go beyond that, you get these much, much higher abatement costs than you do damages, okay? That's why I said it was optimal, cost-benefit analysis. Now, just before he was describing that in his Nobel Prize speech, a guy who's got a PhD in industrial chemistry, working with 16 other people, by the way, disparaged this guy's work in the correspondence I had with him on Twitter. I forgot to ask him what he thought of the other 16 authors, or thereabouts. Okay, a PhD industrial chemistry. This guy knows what he's talking about. It's in industrial chemistry, applying it to climate change. Maybe there are some errors, but here's what he had to say. 4 degrees warmer, tropics and subtropics uninhabitable. Current large agricultural zones become unproductive. Sea level rise 20 to 40 metres at some time away. Maximum carrying capacity of the planet about 1 billion people, compared to 7.5 billion today. So if you've seen that guy who founded Extinction Rebellion quoting the 1 billion persons surviving, so 6.5 billion people dying courtesy of climate change, this is the figure he was using. I've been in touch with Stefan since then. That's the gap between what the physicists and engineers and chemists and scientists are saying and what the economists are saying. And they do not communicate with each other. They listen to each other, but ignore each other at the same time. Economists, because they think they're being consistent anyway in some strange way. Physicists, because they don't expect shitty behaviour like this by a professional. And I've shown some of this stuff and they've been horrified. Now, how can you square them? You know, it's just 3 totally different. What the economists are doing are pretty much 3 methods. This idea they can direct estimates of welfare impacts using observed variations across space within a single country. Who's that, do you reckon? It's your mate, Toll. Okay? Assumes the variation of economic activity with climate over chase holds over time as well. In other words, you can use the current GDP temperature data to predict what's going to happen with climate change. So what they did, they took temperature and income by region data for the USA initially. You find a weak quadratic relationship between temperature and GDP. You then assume the same relationship will hold as you increase the temperature of the planet. This is Mendelssohn describing it. The climate response functions were quadratic in temperature. So again, the quadratic turns up because it's A, it's easy, and B, it plays a fair part in utility theory, as you're probably aware. Countries that are currently cooler will benefit. Countries that are warmer would be harmed. Overall, an average of benefits 145 billion a year out of a 2 degree or 3 degree temperature increase, just by shifting that distribution of temperature. Now, of course, this is what I often get when I criticise it. Can you criticise the theory for its assumptions? What's the answer you guys get? Can you criticise the theory for its assumptions? Or do you just check the results of the theory? Milton Friedman said the latter. You can't criticise an assumptions. The test is whether it empirically fits the data. Okay? That's garbage. This is what Friedman had to say. It used to be taught explicitly in courses when I went through economics. Truly important hypotheses will have assumptions that are widely inaccurate descriptions of reality, and therefore the more significant the theory, the more unrealistic the assumptions. So don't complain about whether them being unrealistic. Notice the number 12 there. It's a footnote. I'll come to it in a moment. But the typical refrain, and I get this all the time, is we have to make some simplifying assumptions, which is true. But they don't read the footnote. The converse is not a hold. Assumptions that are unrealistic do not guarantee a significant theory. Now, when you look at how neoclassicals write, it's almost like they're competing with each other to come up with more unrealistic assumptions. It's why I call it the neoclassical disease. When you look at what Toll and Nordhaus and Mendelssohn have assumed, this particular one has got to be the most unrealistic and dangerous in the history of humanity. Because it's not a simplifying assumption when the results of your arguments depend upon it being true. Okay? Okay, that's the idea of the wall. Okay? If my assumption is correct, I could run straight through that wall. If it's not, I'm going to have concussion. It's vitally important for me to go and test and see whether the wall is actually transparent. Okay? So here's an actual simplifying assumption. Assume the rate of fall of an object is 9.8 metres per second squared. And then assuming, of course, negligible impact from the atmosphere. Well, that's fair enough. You make that assumption when you've got a dense object, which is a few hundred metres or so above sea level. Then you can, if you actually tested how fast it falls in a vacuum versus how fast it falls in the air, you wouldn't get much of a difference. Just assuming it doesn't matter is fine. Or if you have a diffuse object like a feather, way up in the atmosphere, drop that before it gets atmospheric effects, it'll fall just as fast as a steel ball. Not safe to make it when you've got a dense object that's kilometres above the sea level because it'll ultimately hit terminal velocity. Okay. Nor for a diffuse object anything other than a near vacuum. Drop a feather and a ball next to each other. By the way, there's a great video showing just that I've linked on that rate of fall object there to take a look at it, actually done in a vacuum chamber. Okay? Dropping a ball, a lead ball of some sort, not a lead ball but a heavy ball, and dropping feathers with the air there and then doing it without. It's beautiful. Brian Cox is the guy who does it, the English physicist. So what you've got is what an excellent philosopher of science called Alan Musgrave described as a domain assumption. Again, Musgrave, look up, he made a great critique of Friedman. And the domain assumption is true. With the assumption is true, then the theory is correct. If the assumption is false, the theory is wrong. Okay? Now, this is an example, and neoclassicals do this all the time, which is why they let this garbage get through, why they referee it and give it a free pass. This is Sharp. You probably don't know this from the capital asset pricing model. This is his original paper. To derive the model, he derived a model of a single individual. And then how do you get to having a model of the whole economy? He simply extrapolated and said, we assume homogeneity of investor expectations. Investors assume to agree on the perspective of various investments, expected values, standard deviations, and correlation coefficients. Okay? He said, undoubtedly unrealistic. That's obviously false, isn't it? Otherwise, there'd be no dinner party conversations of whether Tesla's in a bubble right now, whether Tesla's well-bounded, okay? That's a classic example happening right now. You're having those debates. It's obviously false. So what happens if you actually admit that it's false? Well, I'm going to say that it's disastrous in terms of the resulting theory. The capital market line no longer exists. There's no single optimal combination of risky securities. The demise of the capital market line is followed immediately by the security market line. The theory is in a shambles. Who said it? Sharp. Okay. A book I've unfortunately lost. I've got to go back and see if I can find the actual reference. But that's himself commenting on what happens if the assumption's false, which it is. So you've had a whole theory of finance based on a false assumption, where the falsity of the assumption destroys the theory. No wonder we found it didn't work. Okay? This is the sort of thing economists do all the time. Now, the Nordhaus, same sort of story. 87% of industry unaffected by global warming. Well, you better damn well go and check that. Okay? Don't just make it for the sake of simplifying your analysis and ignoring 87% of the economy. Assume the observed variation of economic activity with climate over space holds over time as well. That is what's called an assumption of ergodicity. Have you heard of the term ergodic? I highly recommend looking at the work by a guy, Ole Peters. Ole Peters. He's a mathematician working with developing what he calls ergodicity economics. And it's actually not the economics of ergodicity, but the economics of non-ergodic processes. What ergodicity means that what happens over space happens over time. Okay? The ensemble average is the same as the time average. But that does not apply to finance, and it also doesn't apply to climate change. But that's what they assume it does. So you can't just assume 87% of industry is not going to be affected. You can't use current data as a proxy, but that's what they've done. So what they ended up with is, this is a set of points from a table by Toll. By the way, you can find some very interesting correspondence by statisticians on the web about this particular paper. Search for the word Toll and gremlins on the web. Okay? Make for interesting reading. Now, in that, here's Mendelssohn's 2.5 degrees Celsius change causing a 0.1% rise in GDP. That's the early numbers I gave you there. So there's 14 data points on that table that Nordhaus used to fit his dice function. And there's Mendelssohn's data point, one I was discussing beforehand, 2.5 degree increase in temperature, about a 0.1% rise in GDP. There's other ones that make the same assumption, that you can use current data to predict what's going to happen over time. That's one by Nordhaus. Notice there's only 14 data points. Okay? Can you imagine fitting something as significant as climate change to 14 data points? And what sort of data? We are currently at this level. Where'd they get these ones from? The whole lot's been made up. Okay? Nordhaus had the hide to write a paper called Measurement Without Data to critique the limits to growth in 1971-72, the predecessor of the limits to growth. Measurement without data. And this is what he's done. So, the coefficient for that, when you've got a quadratic, the only thing that matters is the quadratic. Y equals x squared. It's a times x squared. What's a? Well, he's reduced it to 0.00227. In other words, for each 1 degree increase in temperature, GDP will fall by 0.00227, less than 1/4%. So that's where a 1 degree change causes a 0.227 fall. 2 degrees causes less than 1%, 4 just over 3.6. Even with 10, you're saying a 10 degree increase would just cause a 23% fall in what GDP would be in the complete absence of global warming. Now, that's only true if that assumption holds, if you can use variation over space for variation over time. And here again, same as what I put beforehand. Now, because I flushed this out into Twitter, of course, you get somebody else diving into the conversation. A meteorologist called Daniel Swine wrote in saying the global climate 10 degrees warmer than present is not remotely the same thing as taking the current climate and simply adding 10 degrees everywhere. That's been validating that assumption. Somebody knows what they're talking about. So the assumption should have been thrown out on that basis. Now, it didn't stop Toll. Climate determinism has no empirical support. And saying if a relationship does not hold for climate variation over space, you cannot confidently say that it holds over time. Now let's put that in energy terms. If a relationship does not hold with no change in global temperature, then you can't assert that it does happen with a change in global temperature. Not so smart anymore, is it? Okay, it's not over time we're talking about. If there was no change in energy level, then yes, that'd be fair enough. We're talking an enormous change in the energy of the biosphere. So what they did, they compared GDP and temperature in two different places while the biosphere temperature level remains constant. What global warming was going to do was increase the temperature of the biosphere. So what you've got is something that gives you information about any trivial role that temperature has in determining GDP today, but nothing at all about what's going to happen if you raise global temperature that much. So I'm going to give you an example of that, just for the sake of exposition, because if you think about the temperature of the planet, you know what the temperature of the planet is in the absence of greenhouse gases? Are you aware of that? Anybody? Yeah. Minus 18. Okay. So that given where the Earth is in the Goldilocks zone around the Sun, and given the given the absence of naturally occurring greenhouse gases, fundamentally carbon dioxide sets it all off. Okay, otherwise, water vapour doesn't get into the air. You have a frozen planet. That given the reflectivity of the planet, it's about minus 18 degrees Celsius. What it actually is about plus 15. So you've got about a plus 33 combination increase from naturally existing greenhouse gases. So I've actually changed this to a non-linear one just for the sake of you guys before I came along here. So I'm imagining there's global temperature, which is that minus 18, and then local temperature, which is largely determined by how far you are from the equator. Okay, you'd have other variations as well, obviously, but you can say global temperature and local temperature, and say GDP per capita is a function of those two, where I've got a quadratic relationship for a global temperature and a quadratic relationship for local temperature. And the only question with the quadratic has been the difference between current temperature and the pre-industrial squared is the value of the alpha 1 and alpha 2. Okay. So what they effectively did, if you look at Florida, Florida's about 7 degrees warmer than the average United States. Okay. So the global temperature, the local temperature, GL for Florida is plus 7. So if you look at the relationship for Florida, you're going to say it's alpha 1 times GT squared plus alpha 2 times 7 squared plus an error term. Look at Dakota, that's actually about 10 degrees colder than the average for the states. So those are your two. Now, subtract both sides of the equation from each other. What you get is the value for alpha 2. Okay? Alpha 1 cancels out. What they're funnily, you can solve for alpha 2, that's what their data is all about. But they have no information on alpha 1. That assumption Ptolemy that looks so sane is actually assuming that alpha 1 equals alpha 2, if you broke it down that way. Now, to me, it's a bit like, I'm always trying to find analogies that make sense to people. Imagine you had data on the slope of a mountain going north to south, okay? Nice and flat. Would you advise hikers that it's quite safe to walk east-west because it's flat north-south? On a perfectly smooth mountain, maybe, but if you're standing in El Capitan, they've got about 20 metres before they die. Okay? Now that's effectively what's going on there. That's why it's so questionable, why it's such bad work. That's why I'm normally not this angry when I get even talking about neoclassical economics. This is life-jeopardising stuff. I first came to prominence in general the public with my stuff on the financial crisis, starting back in 2006, that a crisis was highly likely because of the level and the rate of growth of private debt. But my wife, when I first spotted this, was actually ex-wife. It was actually December 18, 2006, and she woke up in the morning. I said, "There's going to be a financial crisis." Now, her first question was, "What's going to happen to us?" And I said, "Well, if I get acknowledged for having warned of it, we'll be on easy street. Okay. This one, we'll be dead." Okay. There's no bright side for anybody in this one. And part of the reason why we have this difficulty, why we don't say this is nonsense straight away, is because we've never experienced temperatures like this. It's never experienced in the history of humanity a temperature of more than 1 degree Celsius above pre-industrial levels. The variation over the life of our species hasn't been +1. It's been -4, but it hasn't been +1. And -4 was back at the level of the last ice age. If you go backwards and look at the actual recorded data we have between from 1800 and then implied data for a whole range of different techniques back to 20,000 years ago, you find that 20,000 years ago the temperature is about 4 degrees below pre-industrial levels. Okay. Now, what did the world look like then? Well, it looked like, I'll show you in a moment what the ice ages look like. But you can actually use this to test the veracity of Nordhaus's function because it's quadratic. It implies exactly the same damages for a negative shift as you do for a positive shift. Okay? So what does he imply for a 4 degree fall? Read it off as a 4 degree fall, 3.6% fall in GDP. That'd be it. If we were talking about whether they're going to face an ice age. Now, if we actually were facing an ice age and he put these figures out, people would say you're a effing lunatic. Because what did the world look like? It looked like this. Okay. Goodbye, Canada. New York was under about 1 kilometre of ice too. Chicago. Everywhere north of Bonn, pretty much in Europe, under ice. Anybody told you that's going to make a 3.6% degree percent change to GDP, would be laughed out of the room, because we have the historical experience. Because we don't have the experience of temperatures that higher, we don't actually say it's sheer nonsense, but it is. So we can't extrapolate from current conditions to what's going to happen in a world like that. And all of them use something of that nature. Polynomials, some use higher order than Nordhaus, and the higher ones can give you more of a sense of curvature. But Nordhaus is the mildest of all, and he's the one who got the Nobel Prize. Now, again, I've shown you this Lenton quote again. That's the sort of misrepresentation that's been happening in this area. And why do they ignore them? Well, if you have cost-benefit analysis, you can't do cost-benefit analysis if you talk about infinite damages at some point. Okay? You've got to have a definable area that's your damages. So climate scientists say we're going to have discontinuity, we've got to take them into account. Economists use techniques that can't handle tipping points. They throw some fudges in at various points, but the fudges they put in actually have no relation to what the physicists themselves are saying is likely to happen. And this is Stefan. I mentioned the Lenton paper to you for Stefan and Lenton to publish this paper together with another 20 people in 2018. So with trends likely to continue for several decades at least, the contemporary way of guiding development based on theories, tools and beliefs of gradual and incremental change will not likely be adequate. Now, that's the polite version of what I've been saying. And you look in the literature, you can find angrier and angrier physicists starting to realise what the economists have been doing here. Okay, so I would actually be in favour of getting rid of them all, or minor pace, bring in some non-orthodox ones who actually do have some awareness of what climate change means, or get the climate scientists to vet their assumptions. Okay. And what you've got is they're not denying that it's happening, they're denying that it matters. It's trivialisation disguised as science. And here, what happens, of course, you all heard Bjorn Lomborg? Okay, good mates with Richard Toll. And they are feeding Lomborg with the comments, the arguments that let him continue trivialising on behalf of the oil companies and so on that he gets financed by. So he has update of IPCC, the damage functions, tiny, again, the same tiny damages I showed you beforehand, 5% for 3 degrees, that sort of thing. 6 degree, likely to be the loss of 6 to 12% of GDP. I mean, the world will be 3 times richer. Problem, but not the extinction of humanity. Less than 2%, cost of a policy 6, why bother the policy? Kids striking for the future, only 2 to 4%. Again, all telling them it doesn't matter. This is my favourite. Climate's a problem, but nowhere near extension. IPCC impacts smaller than most other drivers. And that's, of course, I've quoted that to you already. And I've also pointed out that's the high agreement number. That's the groupthink. They all think the same way, including some very nice people I know in this area. It's not just people I'm angry at like Toll. It's a couple of very nice guys who still are doing the same thing and just not aware they're doing it. And of course, there's your mate Toll. So, I had to rely upon what climate scientists tell us about this, and they're scared, getting very, very scared about 2 degrees, given what they say are likely to be cascades. And I'd use the model that Stefan and co have built, not a model yet, it's a set of empirical guidelines, starting from that Lenton paper that Nordhaus falsely said supported having a damage function without tipping points. They've then gone on to say what are the major components of the climate that are likely to tip at different temperatures, and then what happens when one tip, what will it do to the others? And they talk about tipping cascades. And so their final, there's a paper, the Lenton paper in 2008 has this graph without numbers and without interrelations. This brings them in. So 1 to 3 degrees, these go. We're seeing Arctic slow ice disappearing already. That then causes thermohaline changes. That causes El Nino to change. That will affect the Amazon, West Antarctic, etc., etc. Once you get past 2, it's a runaway process potentially. We may already be a runaway process. That's what we're using, not data that economists make up to suit their own belief that it doesn't matter. It's unfortunately what we've done. And I've shown you the fact I can do alternative models. I've just shown you that good one earlier. So that's a very, very early. That is by no means the most sophisticated model being done by non-orthodox climate change economists. Okay, just happens to be the first one that includes energy inside there, and of course I was the one who wrote it. But what you've got is feedbacks that are left out of Nordhaus's work. And that's what gives you the real non-linearities. Feedback's one point to another. Now, as I said, I'm not the first economist to criticise these guys. They've got away with it. And by giving them Nobel Prize to Nordhaus, it's been further, their point's been further legitimised when it's been attacked by mainstream economists. So here's DeCanio in 2003 saying the modelling has been a bias against bold and timely action, going on 20 years ago. Pindyck in 2007, crucial flaws that make them useless for policy analysis. Okay? They create a perception of knowledge and precision that's illusory and fools policymakers into thinking there's some sort of scientific legitimacy behind the models. So, one point I make to people actually believe in neoclassical economics. You know I don't. Okay? People who believe in neoclassical economics should be the main enemies of these guys, because when it all comes a cropper, it'll be these assumptions that lead to people saying, let's burn every last neoclassical textbook or bury them. Okay? This is what's going to delegitimise far more so than intellectual failure. And I think what we're actually doing is sacrificing humanity on the back of these so-called simplifying assumptions. So now I cover a lot more of this in my I have a website on Patreon. I'm no longer working at a university. I'm supported by crowdfunding these days. So here's a few. I'm going through them. I simply can't believe how bad this stuff is, which is why it's taking me so long to get through it, because each paper I have another ridiculous claim. Where the hell's that got from? Go back and try to find the foundations, and it tends to be as rotten as that one I showed you in 2000. That's in 1991. So there's a few, and I've taken a break right now because I'm working on the next edition of Debunking Economics. I've got to get that done in the meantime. But it's really, really bad work. And yet it's the basis of how we've responded to climate change. And I think it's every bit as responsible for the circumstances we're going to find ourselves in as Enron and all the other companies that actually make money out of this stuff. I hate to say thank you, but that's the finish. Wow. I normally get a stunned mullet effect when I talk. I think I'm very stunned. Any questions? And I've got a few from you so far, but any comments? Yeah.
I recently read a paper which has been personally quite troubling for me. I don't know if you're familiar with it. Deep Adaptation by Jem Bendel.
I haven't read it yet.
So basically the paper's argument is that in light of the current climate data, it is highly, and in light of the lack of deep substantial economic changes that we've done in the whole production process, that in all likelihood we won't be able to stop climate collapse, and that this point has been criticized by other climate scientists, but more or less Bendel's conclusion is that civilization as we know it will collapse within 10 years. So do you think that perhaps in a way we should, even beyond looking at an accurate model for climate or for ecological economics, that we should look for maybe like a post-ecological economics, or thinking how can we deal with climate collapse, how can we deal with the situation post-climate collapse?
Yeah, I think that's what we're going to face. I mean, 10 years is, I think, unfortunately, potentially quite realistic as well. That was the limits to growth prediction, was about 2030. By the way, you might see, if you look on Twitter, I turned down a vote with Ted Nordhaus. A bet with Ted Nordhaus on the limits to growth. The reason I turned it down was I've been strung up with the bet once before. You get the timing wrong and you get screwed because they get the timing wrong. The effect still happens, but you get the timing wrong. Or when you talk to a journalist, all they want to know is how's the bet going. You're trying to critique the theory, and all that you talk about is the bet. So I turned it down. After saying I will agree to the bet if you read and respond to my critique of that 1991 paper by your uncle. And he wrote back to me and said, oh, well, I suppose he based the reduction in the electricity cost on his research into lighting. Now, how about that bet? And I said, no. You'll call that a response? There's 4 points that I made in that paper. It's valid to say electricity demand levels have fallen because we've gone from incandescent lights to LEDs. But you can't apply that to the whole of energy. You can't give them a free pass on the 87%. Etc., etc. So no, I won't do the bet. I would have done the bet if he'd engaged, but he didn't. And again, this is this self-reinforcing cabal, where the fact that they agree with each other, they all think they're really great. It's all internal, and they don't take criticism on the outside. So I just turned that bet down, but I think that is potentially realistic. certainly I've said my perspective in 2030 to 2050 across that period, given what we're doing, I can't see us avoiding a serious breakdown in the productive and sustainable pattern of the planet, not just because of global warming, it's all the other pressure we're putting on the planet as well. And to put that in an energy perspective, the number of people, when the limits to growth came out, there were about half as many humans on the planet, and the per capita energy consumption was about half what it is today. So we've increased the load on the planet by a factor of 4 over that roughly 50 years. We'll do it again in another 20. We'll double it again. So that load, I think the planet's just going to say, sorry, good night, Josephine. I can't cope with this without dramatic changes to the climatic system, which will happen to drive you to extinction, but that's your problem. Okay? The planet will continue to exist. Some forms of life will continue to exist. But we're going to be forced to go radically backwards at some point. We've so massively overshot where we should be at the moment. And there's things like, have you seen what's called the human ecological footprint? Okay, have a look at that. Talking about how much of a load we're putting on the planet with roughly 1.6 renewable planets per year just to support us. The coronavirus is not caused by climate change. However, when 90% of the mammalian mass of the planet is either humans or the animals humans breed, where's the most sensible place for a pathogen to decide to specialise? Okay? All these sorts of effects are things we should have been conscious of, and if we had an ecological view of the planet, we would have been conscious of. Instead, we've let it get to this point. It's a long answer to your question, but yeah. Pop me the reference and I'll search it out. Yeah. I think you were, behind, yeah?
I'm not an economist, but...
Lucky you.
What is your opinion on the concept of degrowth? How feasible do you see it? Do you think people will, feasible question, do you think we will do it before shit?
No, I don't. I mean, this is partly politics and partly humanity. Human societies have lived on unsustainable trends throughout. I mean, the Roman Empire on a sustainable trend. A lot of them ecological. There's actually a debate today. Toll made the mistake of saying somebody gave only 4 examples, and the person followed it up with a paper giving 28 examples of societies which have collapsed over ecological overload. When it's happened, it's been localised. There's been somewhere else to go to. And so we've our society's evolved in what's called the fertile triangle, the fertile crescent, which is now a desert. Okay. Syria, that part of the world, was where we first evolved agrarian societies. You wouldn't try them today on the same scale as they happened back at the time of Sumer. So these societies tend to collapse. We don't actually react to an unsustainable trend until after it's broken down. So that for a reason I think we'll do a breakdown and then have to cope in that position.
In light of all this, I don't know if you're familiar of the degrowth paradigm?
Yeah, I am. I get if the question was asked. I just don't think it's feasible. I mean, because to do that, like, and make a decision, there's 2 ways you can stop a car. You can put the brakes on, or you can hit a brick wall. I can see humanity hitting a brick wall, and then it has the same effect of putting the brakes on. You do stop. So unfortunately, I mean, I'm talking to people in degrowth. Of course, I've got links in this literature and those lobbyists, but I just think we're going to overshoot. We have overshot. When we realise how much we've overshot, the only way to reduce the thing will be to go on a war footing. The market economy doesn't cut it. So my expectation is we'll need literally military control and rationing at some point. That's going to go on YouTube, which will go down really nicely. Keen's an alarmist. I am alarmed. Yeah.
Yeah, what I'm wondering about is if those economists ever look outside of the window. I mean,
Yeah,
they're
that's
so
right.
into that GDP bubble, while GDP even is a great measure of welfare.
Yeah.
They don't see what's going on in the world, like those forest fires in Australia, for
Yeah,
example.
yeah.
And then you can think that that's all fine, it's all about GDP. I mean,
Yep.
that's just such a messed up way of thinking anyway.
It is, yeah.
That's the paradigm that's accepted by politicians. It's not really a question, but I'm just
No,
so surprised that it's still so much everything we can talk about. Well, it's such a stupid number that says nothing.
I know. I mean, they reframed the debate that way. Nordhaus was the fountainhead of all this stuff. So he disparaged the limits to growth study without understanding it in this paper, Measurement Without Data. He actually used the population equation to show their population predictions were ridiculous. But what he'd left out is all the feedback effects that had the equation. And Forrester, who's the person he was criticising, Forrester wrote a complete reply showing when you fit in those feedbacks, we fit the actual data for population amongst the other phenomenon that Notter was saying they didn't fit. But it was published in a journal that no economist reads. And so what happened, people think the limits to growth made all these crazy predictions about chromium running out and aluminium and stuff like that. And guess which asshole has quoted that to me in recent correspondence? One Richard Toll. Now, when they say that, it's somebody who either hasn't read the book or is deliberately misrepresenting it because they made no predictions about chromium, aluminium, blah, blah, blah. There was, in fact, a table in the report lifted mainly from the Department of Mines, giving current forecasts using current technology when we run out of various minerals. It was simply they republished somebody else's table. But people then say, oh, they made this crazy prediction, it didn't come true. They quoted a effing table from another government department. So what you get is incredible misrepresentation, even in what's supposed to be academic literature. And again, about looking outside the window. I mean, there's one of the nice guys in this area, a guy called Kamiya Mahadis, who's a Cambridge economist. Very, very nice man, unlike Toll. He's done a piece talking about using the fact that temperature's risen over the last 40 years to fit to the GDP. So it took account of my point about there's no variation in temperature here, so you can't really use the current data. Oh, there's been variation in temperature, so we can use that. Fits a model which is quasi-non-linear because it has Cobb-Douglas production functions inside there, but the fit's clearly linear. And he then says that the change in GDP will be by the 0.4 degree per year increase in temperature from now to 2100, which is pretty much 3.2 degrees more temperature. GDP will fall by about 7.23%, literally 7.23. I laughed about it because it was, rounding error. 7.23%. But he defended it away. He's been very nice about it. Said it's big and we should really worry about it. If I was told my income would fall by 7.23%, I'd be worried, etc., etc. Thinks it's significant, but it's just a linear extrapolation of current conditions. Now, I said this is a bit like saying you work out using econometrics that the speed of an ice skater depends upon the temperature of the ice, and for every 1 degree increase, the space skater goes 2% faster. So you predict if you raise the temperature of the ice from -2 to +2 degrees Celsius, he'll go 8% faster. No, he won't. He'll drown. There's a phase change, and it actually said it must be understood that we continued assuming that this shock's Gaussian. Okay, in other words, they're leaving out what matters. And another paper that talked about nonlinearity rather than linearity, that again extrapolated current nonlinear conditions forward. So to me, a lot of it's just playing with econometrics. You've got all these techniques. You want some data to play with it. You want to do your regressions and get your correlations and do your Granger causality and all this sort of stuff. And it's all getting a bit worked up over technique, totally irrelevant to the issue you're looking at. And again, this is what I call a neoclassical disease. Yeah.
I have two questions. So the first one a bit easier. So taking aside the point that by 2030 we may face a human extinction event. So let's say hypothetically we were able to kind of use another planet, to kind of
okay, sorry. Yeah.
Let's hypothetically, right? But to take
this is a pretty good assumption here.
It's a pretty good assumption, right? But a lot of the productive processes, right? Like in terms of, let's say, manufacturing goods and whatnot.
Yeah.
Right? Leaving aside what the economy and advanced Western societies has increasingly become, right? Service oriented, right? We still now face the same issues with, using our environment as basically a giant heat sink.
Oh, of course we do.
For the production, and in terms of raising the.
Yeah.
So that would still not. So then there is a hypothetical limit to economics.
Well, there is in that sense. There's actually an excellent paper called "Finite Physicist Meets Exponential Economist." You ever seen it on the web?
I'm sorry.
Okay, find it. Finite Physicist Meets Exponential Economist. And it's a dinner where a physicist sits next to a leading economist. I thought it might have been Paul Romer. I found that it wasn't Paul Romer, but some leading economist. And they had a conversation about whether you could have indefinite growth on the planet. And the guy pointed out that even if you look at the rate of growth of energy consumption per year, it's about 2.3%, I think it was. He said, well, every 30 years you double the energy load, okay? But that's divide 2.3 into 72 or 69, or 69 or 72, and you'll get the rate of doubling. He said if you extrapolate that forward, using the second law of thermodynamics, in about 400 years, I think it's 250 years, in 250 years the temperature of the planet will be enough to boil water.
Wow.
Okay. Take it forward another 2,500 years, temperature of the Earth, same as the temperature of the sun surface. Okay. So that's a thermodynamic limit. Then he said you keep on going further and say, what if you harness the whole galaxy, and then how far do we go to harness the entire universe? We actually run out of energy. So you can't continue that energy trajectory. It has to flatten. But it's feasible to imagine what they call Dyson spheres, if you've heard of that.
So
Yeah.
I get that, but that energy has to be intimately linked to information, right? And right now there's a huge efficiency loss in that production of energy into into the increase in entropy, right? And so like if you hypothetically say, again, a lot of simplifying assumptions.
Yeah, you'd get. You see, this is the hassle when you're applying efficiency versus exponential functions. You might double your length of time. Okay.
But it doesn't end the.
If you're at 50% efficiency and you get to 100% efficiency, if that were possible, then you'd buy yourself a couple of years.
Right.
With an exponential process. So you have to want to say there are limits. Those are of course literally astronomical limits, but there are limits. And what you should be trying to do as a species is hit a point where you get a maximum level of consumption. It could be well above what we consume now. If we actually took production off planet, you could have a lot wealthier world than now for sure. That's a couple of centuries away if we're lucky, but it's feasible. I certainly don't rule it out. Okay, that's why you're already seeing Bozos and one other are trying to bring back an asteroid, and the whole idea of asteroid mining and things like that. Yes, that's a feasible direction for humanity, but even that one has limits. Okay, so you've got to simply say there is a limit to the level of energy consumption we can have, and a huge part of our wealth as a species is the amount of energy we consume. And none of you even think about hopping in a train and coming over here from wherever you're living in Amsterdam. You wanted to be a king travelling that far, that in that much comfort, a century or two ago, consuming far less energy than you consume. So a huge part of our increase in wealth has been the increase in energy consumption. But at some point we have to stop.
Let me ask you my second question. So, do you feel that, or do you think, right, that part of the reason why you have kind of these specious papers by Nordhaus, by Toll, right, and kind of the more mainstream economic literature, is a lack of the mathematical language necessary?
Yeah, that's a large part of it. Economists have invented their own mathematical language, all the stuff you do for equilibrium modelling and so on. I showed you Minsky a short while ago.
Right, I'm familiar with Minsky, but is there a mathematical rubric that...
Yeah, well, it's thermodynamics.
To this?
Thermodynamics is the fundamental one. Okay, I'll just show Minsky. The reason being, I can bring up a Minsky model by a guy called Tim Garrett. Actually, it's a fine. Let's see. This is a Tim's model based on hang on a sec. Based on thermodynamics. I should have got that. See. Why am I not getting? Hang on. Okay, that's right. Okay. So this is a model, a Minsky model of Tim's thermodynamically based model. And, pardon the errors, the location of the... Actually, I'm going to take a shot of that because that's a bug in Minsky. I'll come back to that. We're developing the software quite radically right now, and a few bugs are turning up. It's an obvious another one. What this is based on is the idea of analogy from thermodynamics to economics, and saying that what civilization fundamentally is a heat engine. We have an available store of energy, which we exploit to produce civilization, and we have to dump the waste in the environment. Now, exactly the same mathematics is used by Tim and others to describe clouds. Okay? So you have a heat source, which is normally the ocean, okay? Which the structure of the cloud is driven by exploiting the heat energy, and then it dumps the waste into the environment. So he draws a plateau with a cliff, and the size of the cliff is this sort of energy return, energy invested. The breadth of the cliff is how much of that resource humanity is exploiting right now. Then you have the humanity itself, which uses all these processes to produce output, and then the environment on the other side. And putting that all together, what you have is a feedback from, he has a relationship between energy consumption and wealth, not GDP but wealth. A different relationship to mine, different mathematics to it. And what he then has is, well, you can carbonise or decarbonise. So I've got, if you don't have any decarbonisation, then he's plotting what's the relationship between atmospheric CO2 and GDP. And so that's the equations in the background here. So those are the equations you need. That's the answer to your question. And to get the paper for it as well. Tim Garrett, No Way Out.
Tim Garrett's paper.
Pardon?
Tim Garrett's paper. Right?
Tim Garrett, Garrett. So when you run it, what you get is, for a while, rising global wealth, which is, and rising GDP, and then good night Josephine. Okay? Calibrated to hit in about 30 years from now, or 30 years from, I think the data's from 2017. So his prediction over front's 2000. He's not a prediction, it's without no decarbonisation. Now if you decarbonise at a fast enough rate, then you can sustain it. So try the same thing again. I did it the wrong way. Maybe I'll go the other direction, let's see. Yeah, that was more carbonising. Let's go for decarbonising. And then you get a stabilisation of atmospheric CO2 and finally a fall, and you've got a continuing increase in global wealth and global GDP. So saying it's feasible to do it. And the limits to growth are the same thing. A different modelling framework to Tim's. But it would have been feasible. And I think it would have been feasible to stay within the planetary limits if we'd taken limits to growth advice in 1975, which is what they said we did. They wrote it in 72. They said if we start by 75, we have 3 years to get ready, and then we can have controls on a whole range of things, including population. Okay? And the limits to growth was disparaged and destroyed by economists, in particular William Nordhaus. Yeah, so it was feasible. And the degrowth is also feasible in that sense, but the rate at which it's necessary is likely to be far faster than we're ever going to be achieved by policy. And the impact on the public would be so great, they'd rebel against it. And it's like saying, a bit like English people saying, no way we're going to put up with this rationing in 1939. And they would have been speaking German in 1940. Well, it's a similar thing for us here. I do think we won't make the decision until you see it as actually an existential threat. And it won't be perceived as an existential threat until it is. And at the moment, except for bushfires in Australia and coronavirus, it's pretty sustainable. So it's a question of how many things like that do we need before people start to say, holy hell, something seriously bad is going on here. Not only should we do something about it, I'm willing to put up with rationing, for example, one of many things, to counteract it. And then what's the political ramifications of that? What sort of world do we get ourselves in? If we say, well, how did our leaders get us to this position? Who's responsible? I can tell you a couple of lemonade. Not anybody in the room, but yeah.
I'll propose that we have pizza and then we continue our discussion in a more informal way, because we actually only have the room until 7, although the one is behind us, but I guess let's try to